Okay, this is A2Pure Mathematics. We are on Unit 6 sequences, and we're looking just at the behaviour of sequences and the way they would act. Convergent and divergent sequences. Consider the sequence 3, 2 and a fifth, 2 and a 25th, 2 and a 125th, and so on. Our nth term 2 plus 1 over 5 to the power of n minus 1. Terms of the sequence are getting closer and closer to the value 2, as can be seen in the graph if we plot that. That then converges to the number 2, so that is a convergent sequence. Most sequences tend to be divergent sequences. If you just have something simple like 2n plus 1, that's a very straightforward sequence. I put in the number 1, I get 3. I put in the number 2, I get 5. I put in the number 3, I get 7, and so on. It goes up slowly, it goes in 2s, but it just heads off to infinity. That's what divergent means. So it just gets bigger and bigger and bigger. Whereas convergent, it doesn't matter how big a number you put in here, it doesn't get any bigger. It just gets closer and closer and closer to the number 2. I hope we're okay with this formula here. If I put the number 1 into this, so what's going to happen? It's 2 plus 1 over 5 to the n minus 1. So 1 take away 1 is 0. 5 to the 0 is of course 1, so that's 1 over 1. So it's just 3 plus 1. Sorry, 2 plus 1, which is our 3. What about whenever I put the number 2 into the formula? 2 take away 1, so that's 5 to the power 1, so that's just a fifth. That's where that one's coming from. Obviously I then put in 3. You can see these in are the powers of 5, obviously. So 5 to the power of 3 take away 1, so that's 5 squared, so 1 over 25, and so on, and that's where that comes from. So I've just written here, there's very little to write really in this, but I've just written in that that is a convergent sequence as the number of terms increase, the value tends, and that's a word we use in maths, tends gets closer to definite limit. And again, limit is a word that would be used a little bit concerning sequences as well. So it heads towards the limit, which of course is 2, gets closer and closer and closer to 2. Not all sequences are convergent. Consider the sequence very like the 2n plus 1 one that I had. I've kind of ruined the surprise for you all. In this sequence, as the number of terms increases, the values of the terms increase and tend to infinity. This can be seen in the graph u of n against n. 4n plus 1, we just head off that. And again, I haven't written too much there. I'm just writing that divergent sequence does not converge towards any limit. It tends to infinity. Okay. Next one, oscillating sequence. So if something oscillates, it kind of moves back and forward, kind of about a different point. So here we have then 1 plus a half, 1 minus a quarter, 1 plus an eighth. Hope you can see what the next one would be. It would be 1 minus a 16th. Notice we have the plus minus thing we discussed in the previous video. So how do we get our plus and a minus? We use our minus 1, and this time it's the power of n plus 1. That means the first one's positive, next one's negative, positive, negative, and so on. The one we had previously was minus 1 to the power of n, where the first one is negative. Anyway, 1 plus or minus, that gets us this wee bit here, and it's a half to the power of n. Or if you want 1 over 2 to the power of n, it's the same thing. So a half to the power of 1 is of course a half to the power of 2 is a quarter, a half to the power of 3 is an eighth. So this one, as the number of terms increases, the sequence is oscillating about the value 1, but at the same time getting closer and closer to the value 1. This can be seen in the graph. So this is a convergent sequence that is converging to the point 1, but it's oscillating either side around it. Okay, so all I've written below, this is an oscillating sequence it tends to a limit of 1. Next one I think is similar, but it diverges. So you can see the previous one converges, got closer and closer to 1. This one kind of heads off. So that's where we are. So the formula for this one then is 5 upon minus 2 to the n minus 1. So the minus 2 to the n minus 1 actually flips it back and forward between a positive and a negative, and we're multiplying them by 5 each time. So does this work? Let's see. We reckon our first term is minus 2.5. So if I put in the number 1 into this formula, I get minus 2, and that's a... Oh, sorry, first one's actually 0. So because of the way we've done the graph here, our first value then is going to be 0. So putting 0 in here, we get minus 2 to the minus 1. That, of course, gives us minus a half. So 5 times minus a half gives us then the minus 2.5 here. If you want to write them below, I suppose we could write this is oscillating divergent sequence. And finally then, not really too much to say about this one, a periodic sequence. So a periodic sequence is just one that you can see this just moves between 1 and 3, 1, 3, 1, 3, 1, 3, 2 plus minus 1 to the n. So you're either adding or subtracting 1 then from 2. So as the number of terms increase, the sequence only comprises of the terms 1 and 3. We say that sequence is periodic.